అదే డిజిటల్ గురు.
Good morning, children. Now we'll just revise the points what all we have done. That is, suppose that you have a line, and this line is making an angle. Draw a line parallel to this and pass. So this is x-axis, this is y-axis, and this is z-axis. Now suppose that you the line draw a line parallel to this line and passing through the origin. So that line will make angle alpha with x-axis, beta with y-axis, and gamma with z-axis. Then we defined this cos alpha, cos beta, and cos gamma as the direction cosines of that line. Direction cosines, and they are denoted by the letters L, M, N. So that if the lines are parallel, if two lines are parallel, then their direction cosines are equal. Suppose that there are two lines which are perpendicular to each other, and suppose that L1, M1, N1 are the direction cosines of one line, and L2, M2, N2 are the direction cosines of the perpendicular line, then they will satisfy the condition L1, L2 plus M1, M2 plus N1, N2 is equal to 0. So if the lines are parallel, their direction cosines are equal. If the lines are perpendicular, then they satisfy this property. L1, L2 plus M1, M2 plus N1, N2 is equal to 0, where L1, M1, N1 and L2, M2, N2 are the direction cosines of the two lines. Now suppose that you have to find the angle between the two lines whose direction cosines are L1, M1, N1 and L2, M2, N2. Then the formula is cos theta is equal to mod of L1, L2 plus M1, M2 plus N1, N2. So this is the formula, or theta is equal to cos inverse of. So this is about the direction cosines. And in direction cosines, we have also learned the property like this. Suppose that you know 2 points x1, y1, z1 and x2, y2, z2 are 2 points on the line. Then x1, y1, z1, x2, y2, z2 are 2 points on the line. Then the direction cosine, first you find the distance AB. Distance AB is root of x2 minus x1 whole square plus y2 minus y1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So this is AB distance. Now the direction cosines of the line AB are given by the formula of line AB are given by this x2 minus x1 by this AB distance, and then y2 minus y1 by again AB distance, AB, and then z2 minus z1 by AB distance. So these are the direction cosines of the line AB when you know 2 points on that line. And then what else we have learned in direction cosines? So if 2 points are known, then these are the direction cosines. And then angle between them is given by this formula. And if the lines are parallel, then their direction cosines are equal. If the lines are perpendicular, then they satisfy with direction cosines like this, then they satisfy this property. So this is about direction cosines. Now what about direction ratios? Any ratio proportional to direction cosines is direction ratios. So if x1, y1, z1, x2, y2, z2 are 2 points on a line, then the direction ratios of the line AB, DRs are just x2 minus x1, y2 minus y1 and z2 minus z1. These are the direction ratios. Okay. only you just find the difference like this. Now cos theta formula is given by the formula mod of a1 a2 plus b1 b2 plus c1 c2 by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. This is the formula. Okay, next, in direction cosines, we have also learned one property that if L, M, N are the direction cosines of a line, then minus L, minus M, minus N are also the direction cosines of the same line. And they also satisfy the property that L square plus M square plus N square is equal to 1. Okay, this is for direction cosines. Okay, now for direction ratios, it is this where A1, A2, A3, A1, B1, C1 and A2, B2, C2 are the direction cosines of two lines. Now, if the lines are perpendicular, then they satisfy the condition A1, A2 plus B1, B2 plus C1, C2 is equal to 0, where A1, B1, C1, A1, B1, C1 are the direction cosines of one line and A2, B2, C2 are the direction ratios, not cosines. So A1, B1, C1 are the direction ratios of one line and A2, B2, C2 are the direction ratios of the second line. And if they are perpendicular, then they will satisfy this condition. Now, if they are parallel, if the two lines are parallel with direction ratios, you can have in any direction. So, if the two lines are parallel and if the direction ratios are A1, B1, C1 and then A2, B2, C2, then they satisfy the property A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So this is all about direction ratios and direction cosines. And then in some problems, we solved one problem in the last class, that is, there it is given that the direction cosines of a line are proportional to, there was one problem. So if the direction cosines of a line are proportional to 1, some 5, minus 3 like this, then it means what? Direction cosines are proportional means these are not the direction cosines, they are the direction ratios because they are proportional. They are so the direction ratios of the line are. So this is one thing which you have to observe. When the direction cosines of a line are proportional to some triad like this, it means that they are the direction ratios. So the direction ratios of the line are 1, 5, minus 3 like this. Now we need this idea now in solving these essay questions, long answer type questions. First we'll finish off this long answer type questions and then we'll do the simple 2 marks type questions. Now find the direction cosines of two lines which are connected by the relations. This is one problem and this is another second bit. So one bit I'll do, you can try the second one. Okay? So first bit solution. So how we do is, you are given the equations L minus 5m plus 3n is equal to 0. Number this as equation 1 and 7l square plus 5m square minus 3n square is equal to 0. This is second equation. Now what you do is, always one equation will be first degree like this in LMN and second equation will be in second degree equation. L square, M square, N square equation or LM, MN, LN equation like this. So we'll do one problem of this type and another problem of that type again in the next type of problem. So here if you are given like this. So from first equation you find out any one, either L or M or N, anything you can find out. Here it is easy to find the L value because it has coefficient 1. So L is equal to, so from equation 1 implies L is equal to 5m minus 3n. Now what you do is substituting in second equation we get 7l square, 7 into 5m minus 3n whole square, 7l square plus 5m square minus 3n square is equal to 0. Now expand this. So you will have 7 into, this is 25m square, 25m square plus 9n square minus 30mn. 30mn plus 5m square minus 3n square is equal to 0. Now simplify. 25 into 7. 175m square plus 63n square minus 210mn plus 5m square minus 3n square is equal to 0. Now simplify. 175m square plus 5m square. So it is 180m square. And then this is minus 210mn. And this is 63 minus 3 is 60. So 60n square is equal to 0. You can take 66, 30 you can take common. Uh, 60 you can take common. No? 60 into 6, 3m square. 3m square minus 6. Okay, I'll take and first I'll take 30 common and we'll see 6m square 7mn plus 2n square. Okay, only this. You can take only 30 common. So that means it means 6m square minus 7mn plus 2n square is equal to 0. Now find the factors for this. 6 2s 12, 7. 12, you must find the factors. 4 and 3. 4 3s are 12. So you can write 6m square minus 4mn minus 3mn plus 2n square. Find the factors. So you can take 2 common from this. 2m common. So 2m into 3m minus 2n. 3m minus 2m. Here you can take n common minus n common. When you take n common, it is 3m and minus you have to take common. So minus 2n is equal to 0. So that means 2m minus n. 2m minus n into 3m minus 2n is equal to 0. These are the factors. Now it means that, so it implies that, right? So it implies 2m minus n is equal to 0 or 3m minus 2n is equal to 0. Now we'll take 2 cases. Case 1. So we'll take, suppose case 1. Suppose that 2m minus n is equal to 0. So then you will get n as equal to 2m. 2m is equal to n. Now we'll find out L from this. So from 1 we'll get, from equation 1, we get L is equal to 5m minus 3n. That is 5m minus 3 into n. What is n? 2m. So whichever is convenient you find out. Here because it is n coefficient is 1, we found n value. Otherwise you can find m value later. So this is what? 5m minus 3 to 6m. So that is minus m. So now all are in terms of here. So what is L is to m is to n. L is minus m. M is m only. We'll write m as m only. And n as 2m. Because we have L and n. L and n in terms of m. So m you write as m only. You are taking the ratio here. So these are the direction ratios. These become now the direction ratios. So you can just cancel m and you can write this as minus 1 is to 1 is to 2. So after writing like this, you can write, therefore the direction ratios, the drs of one line, the drs of one line are a1, b1, c1 is equal to minus 1, 1, 2 like this. You can just write the ratio values as I already tried. They become the direction ratios of one line. Okay, now you take case 2. This is case 1. Now you take case 2. So, what is the question? You must find the direction cosines of the two lines. These are just the direction ratios. So now you find the root of a1 square plus b1 square plus c1 square. So what is it? Root of minus 1 whole square, that is 1. 1 square is 1. 2 square is 4. So when you simplify, it is root 6. So now when you know this is another point which we must, when you know the direction ratios, you can find the direction cosines by dividing each of them by root of these squares, sum of the squares. So the DCs of one line, are, what is it? Minus 1 by root 6, and then 1 by root 6, and then 2 by root 6. So this is one value. Next, case 2. We'll take case 2. So suppose we'll take 3m minus 2n. 3m minus 2n is equal to 0. Then from this you can find either m or n. We'll find out m here. M is equal to 2n by 3. Now again from equation 1 we'll get L is equal to 5m minus 3n. So what is 5m? 5 into m is 2n by 3 minus 3n. So this is 10n minus 9n by 3. So that is n by 3. Now we'll find again L is to m is to n. So what is L? N by 3 is to m. M is 2n by 3. 2n by 3 is to n. So you can take n common and cancel. So it is 1 by 3 is to 2 by 3 is to 1. Now multiply the whole ratio by 3. Then it becomes 1 is to 2 is to 3. Now you find out root of 1 square plus. So these are the, so therefore we'll write. Therefore the direction ratios of the second line, direction ratios of the second line are A2, B2, C2 is equal to 1, 2, 3. Now just to find root of A2 square plus B2 square plus C2 square. So that becomes 1 square plus 2 square plus 3 square. So 1 plus 4 plus 9. So that is root 14. Now we'll write. Therefore the direction ratios of the second line are. So we'll write. Therefore the direction ratios, the DRs of the second line, are 1 by root 14, comma 2 by root 14, comma 3 by root 14. So finally you should write now. Therefore the directions cosines. These are the ratios. Therefore the direction cosines of the two lines are. So what are the direction cosines of the first line? Minus 1 by root 6, comma 1 by root 6, comma 2 by root 6. And this 1 by root 14, comma 2 by root 14, comma 3 by root 14. So this is your answer. Okay. So the procedure is like this. First you are given two equations. Just understand the procedure and think that way. You can solve any type of problem. So you are given two equations like this. One equation will always contain L, M, N. You find out either L, M or N. So here we found L. we substituted in the second equation. Then we find the factors. We always get two factors like this. Now first factor is equal to 0. Consider first factor is equal to 0. Whichever you find convenient, that value you find out. And then substitute in this equation and find out the other value. Then take the ratios. Then they become the direction ratios of the first line. To convert them to direction cosines, you take the square root of the squares of this a1 square b plus b1 square plus c1 square. Find the value. Then you will get the direction cosines of first line. In the same way, you find the direction cosines of the second line. So here we got fraction. Let there be fraction. Still you can simplify. So L value is also a fraction like this, n by 3. Then whatever is common, you just cancel out. And then denominators, to find the ratio in the simplest form, you will take the LCM of the denominators. Here the LCM is 3 only. So multiply all the ratio values by 3. Then you will get the ratio in the simplest form. Then write the direction ratios. These values become the direction ratios of the second line. Then you find out this value and then write the direction cosines of first line and direction cosines of second line like this. Okay. So now in the second problem you can find either L or M or N. You can find either L or M or N. So suppose I find N and all. If you find N, you will get different equation. If you find L, you will get a different equation here like this. So finally, I'll just give the answers. The answers for this problem are, the direction cosines are 1 by root 6, and then minus 2 by root 6. And then another line direction cosines are 1 by root 6, minus 2 by root 6, and then 1 by root 6. So these are the values for the second bit. You can try, you can take it as homework. Now we have another two problems which are similar to this. So you will be given again same two equations and you have to find the angle between the two lines. So to find the angle also, you need the direction ratios. You don't need any direction cosines. You can use cos theta formula, a1 a2 plus b1 b2 plus c1 c2 by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. So you can use that formula. If you are finding the direction cosines, then you will use the formula cos theta is equal to L1 L2 plus M1 L2 plus N1 L2. So if you are finding the angle, to find the angle, you must find the direction ratios. That is enough. We can just use cos theta formula. So next problem, find the angle between the lines. Now find the angle between the lines whose direction cosines satisfy the equations. This is one bit and this is the second bit. We'll do the second bit now. So what is it? First we'll take the equations. We are given, given equations are Given equations are 3L plus M plus 5N is equal to 0. This is first equation. And 6Mn minus 2NL plus 5LM is equal to 0. Second equation. Now what we do is, from first equation you can find either L or M or N. Here it is easy to find M value because its coefficient is 1. So from first equation we will get M is equal to minus 3L. Minus 3L minus 5N. Now substituting in second equation. Substituting in second equation we get 6Mn. 6 into M. M is minus 3L minus 5N. 6M into N minus 2NL plus 5LM. M is again minus 3L minus 5N is equal to 0. Now we should simplify this. So it is 6 3 is 18 minus 18L. N is also there. Ln. Then minus 30N square minus 2, I'll write Ln here also. Ln minus 15L square minus 25Ln is equal to 0. So now it is 15L square minus 15L square and then 18, 20, 45. So minus 45Ln minus 30N square is equal to 0. You can take minus 15 common. Then it becomes L square minus 3Ln plus. You have taken minus outside now. So 15 2 is 30. So 2N square is equal to 0. So that means L square plus 3Ln plus 2N square is equal to 0. Now you find factors. 2 1s are 2 plus 1 you can write. So L square plus 2Ln plus Ln plus 2N square is equal to 0. Okay, from these two we'll take L common. Then we'll get L plus 2N. And from these two we'll take N common. Then we'll get L plus 2N is equal to 0. So that means L plus N into L plus 2N is equal to 0. So it means that L plus N is equal to 0 or L plus 2N is equal to 0. Now we'll take case 1. Suppose that, like in the earlier problem, same procedure. Case 1. So suppose that L plus N is equal to 0. So that means L is equal to minus N. L is equal to minus N. Now we'll find out in the third, this equation. We'll substitute in this equation. So we'll number this as 3 otherwise. Okay, substituting in 3 we get, so substituting in 3 we get M is equal to, okay, we get M is equal to minus 3 into minus N, 3L, L is minus N, minus 5N, that is 3N minus 5N, minus 2N. So now we'll find L is to M is to N. L is minus N is to M is minus 2N is to N. So that is minus 1 is to minus 2 is to 1. So now we'll write. Therefore, the direction ratios, the DRs of one line, are A1, B1, C1 is equal to minus 1, minus 2, 1. Okay. Now we'll take case 2. Suppose that L plus 2N is equal to 0. Now substituting in equation 3 we'll get M is equal to minus 3. From this we'll find out L. So L is equal to minus 2N. Okay, so minus 3 into L. L is minus 2n. Minus 3L minus 5n. So that is 6n. 6n minus n. That is n. So now we'll find L is to M is to n. So L is minus 2n is to M. M is n is to n. So that is minus 2 is to 1 is to 1. Now we'll write, therefore, the direction ratios of the second line, the direction ratios of the second line are A2, B2, C2 is equal to minus 2, 1 and 1. Now we'll take, let theta be the angle between the two lines. Let theta be the angle between the two lines. Angle between the two lines. Then cos theta is equal to, you know the formula, mod of A1 A2 plus B1 B2 plus C1 C2 by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. Now substitute the values. A1 is this, 1 minus 1. So minus 1 into minus 2, A1 A2 plus B1 B2, minus 2 into 1 plus C1 C2, 1 into 1 by root of minus 1 whole square, 1 plus minus 2 whole square plus 1, like this. Root of, this is again 4 plus 1 plus 1. Root 6 into root 6 is 6. And here this is 2, this is plus 2 minus 2 gets cancelled. So I'll get 1 by root 6. So theta you must find out. Therefore, the angle between the two lines is, so therefore, the angle between the two lines is cos inverse of, is theta is equal to cos inverse of 1 by root 6. So this is your 1 by 6. Root 6 into root 6 is 6. So it is 1 by 6. That is the answer. Cos inverse of 1 by 6. Okay, so this is the procedure. Like in the earlier problem, you will find the direction ratios. Here direction ratios are enough. Direction ratios of first line, direction ratios of second line, and substitute. This problem is very, very important. And for the first problem, the answer is theta is equal to 60 degrees. For first problem, you will get theta as 60 degrees. Same procedure. I will continue in the next period.
Dear students, in last class we have discussed about the cash book. Now to that topic we are continuing here today. That's about the cash book only. In last class we have learned about that what is the use of the cash book and how many types of cash books are there. Okay. లాస్ట్ క్లాస్ లో మనము నగదు పుస్తకం గురించి, నగదు పుస్తకంలోని ఎన్ని రకాలు ఉన్నాయి, ఆ నగదు పుస్తకం ప్రిపేర్ చేయడం వల్ల మనకి అడ్వాంటేజెస్ ఏంటి, దాని ఫీచర్స్ ఏంటి, లక్షణాలు ఏంటి, ఇవన్నీ కూడా మనము లాస్ట్ క్లాస్ లో తెలుసుకున్నాము. హియర్ టుడే we will discuss about the